Hi and hello, this is Shashank Rao G from the branch Aeronautical Engineering, Watson, of rule number 2295182147. This is a Tech Talk video presentation with subject accelerated course heat and mass transfer. The topic I have chosen for the Tech Talk is optimizing radial heat conduction in cylindrical systems. Introduction. Welcome to the presentation for optimizing radial heat conduction in cylindrical systems. In this presentation, I'll explore the principles and strategies for maximizing heat transfer efficiency in cylindrical structures. Fundamentals of heat conduction. Understanding the mechanism of heat conduction is crucial for optimizing thermal performance. The process involves the transfer of thermal energy to the material due to temperature gradient. Heat conduction is a process of pro process of transfer of thermal energy from one material to another material, usually usually seen in the solids due to the temperature gradient between the molecules which are attached to each other in a solid. The process of conduction involves transfer of thermal energy through a material due to temperature gradient. Radial heat transfer equation. The radial heat conduction equation is a fundamental tool for analyzing heat transfer in cylindrical systems. There is an equation called radial heat conduction for the cylindrical systems, which determines the heat transfer through the through a cylindrical system or a cylindrical body through conduction process radially. It describes the flow of heat in terms of temperature differentials and material properties. Thermal resistance in cylindrical systems. The concept of thermal resistance is essential for evaluating heat conduction for cylindrical structures. If we understand the concept of thermal resistance in the cylindrical structures, it is an essential key for evaluating heat conduction in our cylindrical structures, which in turn we can optimize the heat uh, heat transfer or the conduction process radially in the cylindrical structures. Factors such as material thickness and thermoconductivity contribute to overall resistance. The thermal resistance in the cylindrical systems are dependent on two factors, namely material thickness, the thickness of the cylinder, its radius and its dimensions, and also thermal conductivity of the material the cylinder is made up of. These both are the main factors in determining thermal resistance, which is an basic factor, essential factor for evaluating heat conduction in cylindrical structures. Optimizing material selection. Selecting a material with high thermal conductivity and low thermal resistance is critical for enhancing heat conduction in cylindrical systems. If we select, if we select, we should select a good material for designing a cylindrical system for a very good radial conduction throughout the body. And that material should have high thermal conductivity and low thermal resistance. Factors such as cost and durability must also be considered in designing and optimizing the material. Enhancing surface area. Increasing the surface area of cylindrical structures can significantly improve heat conduction. The surface area of the cylindrical structure is a crucial part in determining the thermal conductivity and the thermal resistance of the cylinder. Strategies such as fins and extended surfaces can maximize the contact area. for efficient thermal transfers. There are such strategies called fins and extended surfaces that can be put in the cylinder for enhanced and efficient thermal transfer. Optimal in Optimal insulation techniques. Effective insulations is essential for minimizing heat loss for cylindrical systems. Utilizing materials with low thermal conductivity and proper installation techniques can prevent energy waste. If the cylinder is insulated well, there cannot be a loss of thermal energy, and we can optimize the radial heat flow to the conduction in the cylinders. Case studies in heat conduction. Examining real-world case studies provides valuable insight into successful strategies for optimizing radial heat conduction. These examples offer practical applications of theoretical principles. Challenges and solutions. Addressing challenges such as uneven heat distribution and thermal inefficiencies require innovative solutions. Advanced heat transfer technologies and computational modeling can overcome these obstacles. Future trends in heat conduction. The future of heat conduction in cylindrical systems is poised for advancement in nanotechnology, smart materials, and suitable thermal solutions. Embracing these trends will further optimization of the heat conduction. In conclusion, optimizing radial heat conduction in cylindrical system is a multidimensional task that requires comprehensive understanding of thermal principles, the flow, the shape, the surface, understanding the basics of fundamentals of heat conduction, understanding the radial heat conduction equation, thermal resistance, factors affecting thermal resistance, materials, surface area, extended surfaces, insulation techniques can lead to a better understanding of thermal principles, which lead to the innovative ideas in engineering solutions. By leveraging these strategies, we can achieve superior thermal performance in various applications. Thank you.